Hi, my name is Emma, and today we are going to be discussing one of the most interesting, or as Einstein called it, spooky phenomenons in the world of quantum mechanics, entanglement. But before we begin, imagine this. You and your best friend have known each other since birth, and you guys are always known for making opposite decisions. When one says yes, the other one always says no. But now imagine your best friend has to move across the globe from you. But when it comes to decisions, you guys still always make the opposite choice, even if you never communicate with the other one how you're going to choose. This is exactly like how quantum entanglement works, but instead of people, it's particles. Let's first talk about particles and their inherent properties. Say this is a particle. Particles have this thing called spin. Imagine you're spinning a quarter on a table, but instead of clockwise or counterclockwise, we call it spin up or spin down. But here's where things get a little bit weird. A particle's spin does not have an inherent direction until it is measured. Kind of weird, I know. This is called superposition. It's a little bit easier to understand like this. Imagine you are bouncing on a tightrope. You are neither on the left nor the right side until you've fallen either way. Just like that, particles are neither spin up or spin down until they have been measured. But now that we understand particles and their spin a little bit, let's bring in this particle's best friend, its entangled counterpart. When one is measured to have spin in one direction, let's say this one is spin up, the other one automatically is going to be spin down. But wait, how can that possibly work if we don't know which way a particle is spinning until we measure it? That's kind of the interesting part. Your gut reaction is probably to say, oh, they're like communicating, right? Yeah, no. They could be light years away from each other, just like you and your best friend across the globe, and still they would always have measured opposite spins. And this is what has been boggling physicists ever since the beginning of quantum mechanics. Now, you may not be fully understanding what's going on in terms of quantum entanglement, but you are not alone. Physicists today still do not understand exactly how quantum entanglement works, but they do know how to use it as a tool. Quantum entanglement is used as a way to communicate in quantum computers, which look a little bit less like this and more like a really pretty fancy chandelier. They're used as a shorthand communication between qubits, which are like bits of information in a quantum computer. Now, quantum entanglement is something that's a little bit confusing and we may not understand it, but it is quickly catapulting its way to the forefront of science. Hopefully it'll help scientists develop more ways to technologically advance and get faster and faster computers. But still, mysteriously entangled particles? Pretty spooky, right?